Hello. The question says that 3 moles of an ideal gas which was at pressure Pa and temperature Ta is isothermally expanded to twice its initial volume. So let us assume that the first state be A, the second state be B. Okay. So initially it was having pressure Pa, temperature Ta, and suppose the volume will be Va. Okay. So what has happened here, that it has been expanded isothermally. So in isothermal we know that the temperature will remain same, okay, and the volume has become twice, so it will be twice of Va, okay, and the pressure here will, let us assume it to be Pv, okay, and it is then compressed at a constant pressure to its original volume, okay. So constant pressure, that means Pb will remain same and the volume will to its original volume, then the volume will become Va, okay, and then the temperature, let it be at Tc. Finally gas is compressed at constant volume to its original pressure Pa. So constant volume, and this will be like constant volume and pressure, original pressure Pa, so the pressure will become Pa and volume will become Va. So this will become, the C part will, the next step will be A, okay, so that it will be a complete cycle, okay. So so this original to pressure is P, okay, so this has become the complete cycle. Now let us see the process AB. So as it is given, isothermal, so this means constant temperature, as I have already written. Constant temperature, this implies Tb is equal to Ta, okay, so I have written the same. So from here, as it is an isothermal process, we can say that Pa Va will be equal to Pb Vb, right? So this implies Pa into Va equal to Pb, Vb is twice of Va, so Va, so this implies Pb is equal to Pa by 2, okay. So now for process BC, that is the second process, it has given us that constant pressure, so that means it will be a isobaric, okay. So this implies that Pb will be equal to Pc, which I have already written, that Pb here, okay. So from here we can see that Vb over Tb will be equal to, as it is isobaric, equal to Vc over Tc. So this implies Vb is given as twice of Va, so twice of Va over Tb is nothing but Ta. Ta is equal to Vc, Vc is again Va over Tc, so let it be Tc, okay. So from here we can see that this implies Tc is equal to Ta by 2, right? So now for the process C2A, so this has given us constant volume, that means it is isochoric, so that means constant volume, okay. So from here we can say that Pc over Tc will be equal to Pa over Ta, right? So from here, as we know, Pc is equal to Pb, okay, as we know Pc is equal to Pb, which I have already written here also, okay, which is equal to Pa by 2, right? So what we can write here is, this Pc is Pa by 2, so this means Pa by 2 Tc equal to Pa by Ta, right? So Pa got cancelled, this implies Tc is equal to Ta by 2, right? So now we have all these positions, or the coordinates of T graph, right? So what we can write is, like in order to draw the graph. Suppose we have to draw this PV graph, right? Suppose this is P, this is V. As we know that A to B is isothermal process. So isothermal process is something like rectangular hyperbola. It will be like this. Okay, A to B, because we can see that at B the volume is double. Okay, the volume is, where is the volume? VA is twice of VA. See, so this will be like 2O 2 VA, and this is VA, right? And the pressure here, suppose it is PA, so the pressure here is PB. Okay, and this is like isobaric, so pressure is constant, and then it is isochoric. This volume is this, so it will go like A to B, B to C, then C to A. So this is it. This is its PV graph, right? Now for PT graph, okay, suppose this is P and this is T. Okay, so what is happening? A to B. A to B is isothermal, that means temperature is constant, and B to C is baric isobaric, that means pressure is constant, and then it will be like isochoric or like this. Okay, so here it will be A, B and C. A to B, B to C, C to A. Okay, so these two both are like we can see that this is cyclic. Okay, so now for, as I said, work done will be W of AB plus W of BC plus W of CA, right? So for AB, as I've said, we have seen here that it is a isothermal, so it will be NRTA ln VB over VA, right? And for this BC, it will be NR TC minus TA, right? And for and for C2A this will be 0, right? So by calculating this, we can write here as 2.303 because it is ln, so converting into log, it will be 2.303 into n is 3 number of moles into R into TA into log of base 10. VB is twice of VA upon VA, correct? So this will be log 2 only, plus 3R, TC is nothing but TA by 2, we have already seen, minus TA, correct? So if we solve this, what we will get? This TA minus will be nothing but minus TA by 2. Okay, so after solving we will get this 0.58 R into TA. Okay, this V will get cancelled, this TA will remain, and here also RTA, so the work done will be same. Okay, so now it is also asking, the question is also asking us about calculate the work done and the net heat supplied to the gas during the complete process. So obviously, as the work done is 0.58 RTA, so the heat supplied will be Q is equal to 0.58 RTA. Because this is a cyclic process, delta U will be 0, and from the equation dW is equal to dQ plus du, this is 0, dW will be equal to dQ only. So this is the answer. Thank you.
Hi everyone, so we are given with a question which says we need to calculate the work done when 1 mole of perfect gas is compressed adiabatically. The initial pressure and volume of the gas has been given as 10 raised to 5 Newton per meter square and 6 liter respectively. The final volume of the gas are 2 liter. Molar specific heat of a gas at constant volume is 3R by 2. So we have to calculate work done in adiabatic process. So we can write for adiabatic process, we know the relation, that is PV raised to gamma is a constant. Here gamma is nothing but it is the refractive index, or it is the adiabatic index. So we can say from here, uh, first we have to calculate this value of adiabatic index. Before that we can write this expression in this way, that is P initial V initial raised to gamma, that is pressure volume raised to gamma, and that is equals to P final pressure into final volume raised to gamma. All right, and now we can say this is, let's say, our expression number one. Now of adiabatic index, that is gamma, is can be written as, it is a ratio of molar specific heat capacity at constant pressure upon molar specific heat at constant volume. So from here we have been given with molar specific heat at constant volume 3R/2. Therefore we can get the value of uh, so now we can use Mayer's relation that says Cp minus Cv is equals to R. From here we can get the value of Cp. Therefore from here we can say Cp will be equals to R plus Cv. So it comes out to be 5R/2, since we have been given with molar specific heat at constant volume as 3R/2. Alright, and this is what the Mayer's relation is. So we can keep it a note over here. Mayer's relation. Alright, so from here we can say the value of adiabatic index which we are getting will be, we just have to take the ratio of Cp and Cv. Therefore we can say gamma comes out to be 5R/2 divided by 3R/2, so this comes out to be 5/3. Alright, now what we can do over here is, we have with us the value of gamma, that is adiabatic index, and so we can say work done formula can be now written as, therefore work done in adiabatic process is given by the formula, that is W equals to P uh, Pi Vi minus Pf Vf dividing by, or we can write this way, so this can be written as initial pressure into initial volume minus final pressure into final volume dividing by gamma minus 1. So if you substitute all the respective values that has been given, uh, that is we have with us Pi Vi and we have with us final volume, but we don't have final pressure. So from equation 1 we can first calculate the value of final pressure, then we will substitute in this expression. So let's say this is our equation number 2. From 1 we can write final pressure Pf can be written as, we can clearly see from it, Pi into Vi by Vf raised to gamma. Alright, so from here we can say if we substitute the values over here, so we can write final volume, final initial pressure has been given as 10 raised to 5, so we will substitute it over here, 10 raised to 5 into initial volume has been given as 6 liters and final is 2 liters, so 6/2, so that becomes 3 over here, and gamma is 5/3. So this result comes out to be 10 raised to 5 into 3 raised to 5/3. So this is what the result we are getting for final pressure. So now we can substitute it in equation 2. So we can write from equation 2, now work done can be written as Pi, that is 10 raised to 5 into initial volume 6 liters, converting it into meter cube, so 10 raised to minus 3. So this is PIVI minus PF. Just we have calculated now. PF is 3 raised to 5 by 3 into 10 raised to 5. Final volume is given as 2 liters, that is 2 into 10 raised to minus 3 meter cube, dividing by gamma minus 1, that is 5 by 3 minus 1. So here we can write it as 3 by 2 into 10 raised to 2, and here we can write 6 minus of what we are left with inside is 12.48. After multiplying 3 raised to 5 by 3 into 2, we are getting 12.8. So final answer comes out to be minus of 972 joules. Alright, so this is the work done we are getting for this adiabatic process. So I hope you have understood the concept, and thank you for
इस क्वेश्चन में हमको वीटी कर्व गिवन है और इसको हमें पीवी कर्व में ट्रांसफ़र करना है। तो हम तीनों प्रोसेस कंसिडर करेंगे, पहले ए बी करेंगे, फिर बी सी करेंगे, फिर सी ए करेंगे, फिर देखेंगे कैसा इसका रेस्पॉन्स आता है। तो पहले ए बी करते हैं, ए बी प्रोसेस। देखो ए बी प्रोसेस ओरिजिन से पास हो रहा है, इसका मतलब जो इसकी इक्वेशन होगी वो होगी v इक्वल्स टू एम टाइम्स टी। एम इसका स्लोप है इस लाइन का, तो हम इसको आइडियल गैस इक्वेशन में डालते हैं, पी वी इक्वल्स टू एन आर टी। टी कैंसिल हो जाएगा तो पी आएगा हमारा एन आर बाई एम। एन कॉन्स्टेंट है क्योंकि हमको कॉन्स्टेंट मास दिया हुआ है, आर गैस कॉन्स्टेंट है और एम स्लोप है वो भी कॉन्स्टेंट है, तो पी आ गया हमारा कॉन्स्टेंट। ठीक है, अब यहाँ पर हम एक पीवी कर्व बना देते हैं। तो पी कांस्टेंट आएगा फर्स्ट इक्वेशन में वी बढ़ाने पर, तो हम मानते हैं कि ये ऐसे आएगा ए बी। ठीक है, अब बी सी प्रोसेस कंसिडर करते हैं। बी सी प्रोसेस में हमको दिख रहा है कि वी कांस्टेंट है। ठीक है, तो आइडियल गैस इक्वेशन देखते हैं, पी वी इक्वल्स टू एन आर टी। तो पी इक्वल्स टू एन आर टी बाई वी, तो P is directly proportional to T because N, R and V are constant। अब देखो BC प्रोसेस में टेम्परेचर डिक्रीज हो रहा है और हमने फाइंड किया कि P is directly proportional to T, तो प्रेशर भी डिक्रीज होगा, तो PC प्लॉट आएगा ऐसे, प्रेशर डिक्रीज होता होगा कांस्टेंट वॉल्यूम पर, इसे मान लेते हैं हम C। अब कंसिडर करते हैं CA प्रोसेस। CA प्रोसेस में T कांस्टेंट है। ठीक है, तो पी वी इक्वल्स टू एन आर टी, इसका मतलब हुआ कि एन आर और टी कांस्टेंट है तो पी वी इक्वल्स टू कांस्टेंट हो गया, तो एक हाइपरबोला बनेगा इस तरह से। तो ये ऐसे बनेगा ए बी बी सी सी ए।